Topic 1-3, Inequalities Applications. This can be referenced with our whole textbook, Chapter 3, Section 4, on page 188, and you might want to look on those pages in that chapter about some practical applications. One of them had to do with making profit on some CDs that a band was going to make, and the cost of the CDs plus recording studio charges, how much per CD they would need to sell in order to make some profit. So there are some practical applications with inequalities that it's a good skill to know how to be able to read these. And you will be seeing these on standardized tests quite a bit because there is so many practical applications. So let's look at a couple of them. If Albert earns $3.50 for each hour he works, which isn't very much, is it? Anyway, so he wants to earn at least $52.50. How many hours must he work? Well, you can kind of guess and check and just kind of see, well, how many that would be. Keep adding 350, 350, 350. But if you want to use an expression of algebra, you would give a variable to the number of hours that he works. So here they've given it h as being the number of hours. If each hour was $3.50 and you want to make at least, that's the key word here, that he could make more. So everything in this value could be greater than, but at least equal to $52.50. How they got this was dividing by the 350. So you take the number of hours that you work divided by how much money that he was wanting to make. So he would have to work at least 15 hours for this particular one. Let's pan that out a little bit. Okay, look at the next one. The daily production cost of a skate factory cannot be more. So this is the key word here as far as setting up the inequality. So everything in my expression cannot be more than, so everything over here is less than or equal to. It could be equal to, it just can't be more than this amount. If it costs $15 in materials to make each pair of skates, so the materials, the P representing the pair of skates, in each one the materials cost $15, and the operating cost, which is a set fee, are $900. This is your expression. So the more you do these expressions, we'll try to do lots of application problems, the better you'll get at these word problems. How many pairs of skates could be produced? The first thing has to be done is subtract 900 from both sides. Again, steps were skipped in showing of the work here. And then the last thing after you subtracted 900 from both sides is to divide by 15. Anytime you're getting a variable by itself, which the P of ultimately was to be alone, the last step in doing so is the division step. Always think divide. Division is the last thing. So no more than 300 pairs of skates could be made in order to produce, how many pairs under their circumstances. So that's how many they could make. Okay, a few more examples before you try to do some on your own. Let's look at number 3. A group of friends went to the movies. After paying for their tickets, they had a total of $10 to spend. So look at where we put the 10. They can't spend more than that, so everything in the expression to the left has to be less than or equal to, because this was the most they had to spend on refreshments. If the sodas, which will represent, it's always good to kind of mark what your variable you've chosen, what it represents. So that represents the sodas were $1.50, and the boxes of popcorn, they already told us how much they were. So if you want to, in your expression, you could write what this was. This is the popcorn. Alright, so after I multiply that, I get $3.50 for my 2 boxes of popcorn purchased. And how many sodas could I buy? So popcorn plus the sodas that we don't know how many we could buy, but I can't spend more than $10. So we're taking the 350, subtract it from the 10 to get 650 left, divide 650 by $1.50, which gives you this much sodas, but you have to understand, I can't buy say, oh, just give me a third of a soda. You have to have a certain amount. So in this case, you have to round to the whole number so that no more than 4 sodas could be purchased. Okay, number 4. Kevin's history grade. This is often one on a standardized test. Kevin's history grade will be determined by the average 4 test grades. If he received a 76, an 85, and a 74 on his first 3 tests, and he needs to get an average of at least, now that at least shows us that it's an equal sign. Maybe we should mark that. That little saying that it could be equal to is denoted by this at least saying. To receive a B, he has to make at least an 80. So could the expression be more than? Yes. So that's why the inequality goes this way. Can't be over 80, but it could, can't be less than 80, but it could be equal to or greater than. So what's the minimum he could make? Well, you know, to get an average, if you've got your grades, and then the fourth one, this is the 4th grade right here that we don't know, and divided by 4. Don't be afraid of an expression that shows a fraction. The thing you have to remember to do in this one is to get rid of this 4, you're just going to multiply by 4 on both sides. If you multiply by 4 over here and 4 over there, those go away. Those 4's go away. So you're left with adding up your numbers, 76, 85, and 74, to get 235. Plus the 1 grade, the 4th grade we don't know, 4th test grade. And 80 times 4 is 320. This is the 4th test grade. So subtracting 235 on both sides leaves you with 85. This goes away. So at least a grade of an 85 has to be made on that 4th test in order to get a B in the history class. Okay, last one. On the interstate highway, the maximum speed is 70. So here's my unknown, the x representing the speed. It can't be greater than 70, but it could be equal to. And the minimum, which means I can be greater than 45 or equal to 45. So this is the way you would express something to write the inequality, express the condition of a minimum speed and a maximum speed. So now go try some on your own in section 1-3.